Welcome to this introduction to data management for machine learning and AI. In today's session, we look at the question of where the machine learning data comes from. As a reminder, as part of the machine learning workflow, we need to obtain training data to train our machine learning models. This training is additionally guided by continuous validation using validation data. And finally, the model is being evaluated using the testing data. Only if the model shows sufficient performance on the provided testing data, we can deploy the model. But where do we actually find or obtain that data? We will briefly discuss 5 approaches obtaining machine learning data. In short, these are: 1. Reusing existing training data made by other projects. 2. Buying and getting data from external data repositories or data marts. 3. Making datasets from internally available data in your own project or enterprise yourself. 4. Employing external workers or people in data farms or crowdsourcing platforms to make the data for you. And finally, 5. Making artificial or synthetic data using AI techniques. Let's have a look at the first option: reusing open machine learning training data. This is probably what most inspiring machine learning developers will do during their training and education. Instead of making your own training dataset, you simply reuse datasets made by other people for other projects in other contexts. For many standard tasks, there are actually several good standard datasets around. But the problem is, what happens if you do not have a standard task? You can then, of course, still try to reuse some of these datasets, but then the big question is if that dataset is still relevant to your task or not. But as you're watching this introduction video, you're probably still in your education and training phase. So reusing some pre-made training and test data is a great way to quickly get a project going in order to practice and develop some machine learning development skills without being bogged down by data management issues. But where do we find such reusable data? Well, a common data source is Kaggle, a platform which specializes on machine learning competitions. Pre-made datasets are provided with a specific task and goal, which are a great way for gain some experiences as a developer in training. Some of these datasets can also be relevant in other projects and can be reused. But of course, also most AI and machine learning courses at universities will provide you with some datasets to use for practice and training. But there are more platforms like this, as for example the Open Data Repository of Amazon, AWS, or the Open Data Search hosted by Google. Just take some minutes and browse around in these platforms and see what you can find. The second approach is to extract data from repositories and data marts and make your own training and testing data from them. Such repositories are often commercially offered by multiple companies, but also by many government institutions. However, these datasets are typically not specifically made with machine learning training data in mind. They are datasets which you can then buy or obtain for free, typically containing summarizing statistics or factual data on certain topics, like, for example, the average air quality in the Netherlands on a daily basis on a 1 square kilometer resolution for 2022. It's a very valuable dataset, but it's not ready for direct deployment in a machine learning system. Extracting relevant data from these repositories and turning them into a suitable test and training dataset is a hard and time-consuming task. Me being in the Netherlands, I use an example, the CBS, the Central Bureau for Statistics, which is a governmental institution in the Netherlands collecting and creating statistical data for the country. Some of the datasets here are shared for free, but many more of them can be commercially obtained or can be licensed for research purposes. Well, at least if its legal restrictions allow to do so. However, many countries also adopted an open government and open data policy. This also applies to the Netherlands, where by political mandate, all datasets which are collected and which are not restricted by privacy, safety or other concerns are to be shared with all the citizens. Many of these datasets can be found in the data repository of overhead.nl, and I would invite you later to browse around in that repository and see what you can find. Or check out the respective repositories in your own country if you're not residing in the Netherlands. To approach number 3. If your AI project is attached to an existing software system or embedded in an existing enterprise context, you might already have data available yourself. So for example, if you run a web shop, you probably already have data on customers, the items you are selling, and the purchases customers do. Similarly, if you host a community site, you probably already have data about your users, the content they create, and the interactions they have with each other. This data typically resides in your enterprise data management system, which also happens to be quite often a relational database system. The big challenge now is, how do you extract data from these systems and transform them in such a way that they can later on be loaded into your machine learning lifecycle? However, I also want to point out that it's not just a technical problem of how to design a data extraction pipeline or how to transform and load your data. Data might be residing in your own system, being collected by your own application. However, if that data was collected from people, like your customers, many legal issues can arise and you can simply not do whatever you want with your data, because it actually might not be yours at all. These restrictions are extensively covered in many regulations, like for example in Europe, in the General Data Protection Regulation, better known as GDPR, or in the new European Data Act. Look these things up for more information. When talking about extracting data from other systems, you will often hear the terms pipelines or ETL processes. ETL stands for extract, transform, and load, and describes a process where data is being extracted from an external database, cleaned, and then transformed and integrated into a format better suited for the intended use, and then finally loaded into a different system, like for example your machine learning training process or a data warehouse. Creating effective and efficient data pipelines is a field of work with many good job opportunities, so maybe pay attention to these things. Approach number 4, which we want to discuss today, would be the use of data farms or crowdsourcing. The problem we want to address with this is that the data we would need does not yet exist at all in any repository, but needs to be made specifically for you and your project. This commonly happens if you have unlabeled data from some other source, but lack the labels in order to use it for machine learning training. As an example, consider that you run a community forum where people can have online discussions, but you want to moderate for hate speech and harassment automatically. Of course, it would be easy to extract unlabeled examples of people text posts from a central database underlying your system. But in order to detect hate speech, you would now need to annotate each post if it contains hate speech or not. Unfortunately, understanding the finer semantic points of human language is a rather complex task, and typically requires another intelligent human being to do so. But how would we efficiently and effectively label, let's say, 100,000 text posts collected from your forum to train a classifier? Of course, you can do this yourself, and then take 5 years, or abuse your employees or students to do this for you. But more commonly, you will look towards crowdsourcing or data farms. Data farms are one-step solution, large businesses, to which you can outsource the whole data labeling or data cleaning problem, and they take care of it using their own workforce, and you simply pay the bill at the end. In contrast, crowdsourcing means that you are recruiting paid or unpaid volunteers, typically using some kind of internet platform, and they perform the task for you. Let's talk about crowdsourcing first. There are multiple approaches to doing crowdsourcing, and one of the more older ones you have probably already encountered several times when browsing the internet. We can see here an example. This would be piggybacking, a crowdsourcing task on top of another task. This is one of the later variants of reCAPTCHA by Google, whose primary purpose supposedly is to decide if the user of a website is human or a machine. But at the same time, it also creates labeled training data for different computer vision systems. So, essentially, every time you're solving one of these CAPTCHA challenges to prove that you're human, you're actually also helping a self-driving car to get better at its job. Another common approach is to use your volunteer community to get the data you need. There are many platforms out there which invite you to provide ratings or reviews for various services and products. And this is typically a very good way to get such labels at scale. Here, as an example, we see movie ratings on the MovieDB. The more traditional approach to crowdsourcing is paid microtask crowdsourcing. There are many platforms which do that, as for example Amazon Mechanical Turk or Prolific. The idea is that you make small web interfaces in which people can perform your data task, like annotate or label your texts, and then these tasks are distributing by the crowdsourcing platform to a large number of users who then can volunteer to do your task, and then you typically pay each person for the contributions they make. The last approach I want to address today is crowdsourcing as citizen science, typically performed by research institutions or public agencies, motivating citizens to contribute data to ongoing research. For example, the Dutch government, in collaboration with the Naturalis Museum in Leiden, runs a study on insect biodiversity in the Netherlands every couple of years. This study requires data which simply doesn't exist yet in any form. Therefore, Dutch citizens are asked to go outdoors and for a day or two count all the different insects they encounter in their gardens and parks and submit this data into a central platform, essentially creating a new dataset using all these volunteers. Now, this brings us to data farms. Data farms share many crowdsourcing ideas, but are typically large commercial businesses which build upon their own data workforce. This really is a big global business with many implications and ramifications from an economic and labor perspective. It is not uncommon to set up these data farms in low-income countries and then hire a large workforce which annotates and cleans up data as their main full-time job for rather cheap. There have been many discussions that such cheap access to labeling work can provide a competitive edge when employing AI systems, as for example pointed out by this article by The Economist you see on the left. Also, data farms, due to their remote work nature, would allow us to bring labor into regions where usually not many paid jobs would be available, as mentioned here by this Financial Times article on the right. However, data farms also open the opportunity for different shades of labor abuse by taking advantage of more relaxed labor laws, as is also frequently discussed. Here an example by the New York Times. This type of data labor is still a new phenomenon, which is not yet well understood and regulated. For example, there are recent discussions about debating the psychological impact of doing data work. Just imagine it would be your 8 hours per day job to provide labels for image moderation in an online platform. During these 8 hours every single day, all you do is staring at pictures of violence, gore, or other explicit content most people wouldn't like to see in their online platform. There are several such workers who reported developing psychological disorders from doing this type of job, like for example developing sleeping disorders or developing depression. While I personally wouldn't know how to regulate or handle this data farm style work properly, let's just take away from this brief discussion that there's a lot of potential for future debates and regulations. The last approach I want to discuss today for obtaining data is relying on artificial or synthetic data. This is a rather bleeding edge approach which is actively discussed in the professional academic community right now. And the core idea is to train an AI system to represent the type of data we are interested in and then generate artificial examples of the same type of data. So essentially, you use an AI system to create training data which then can be used to train another AI system. Why would this be a good idea? Well, modern machine learning algorithms, especially deep learning based ones, require a humongous amount of training data. In these scenarios, having more data available is always better than having less data available, even if the quality of the data is slightly lower than that of manually created data. This type of approach also works well for augmenting existing real data set with additional data points in order to increase their size, for example, for balancing underrepresented classes. Again, keep in mind that using synthetic data is a bleeding-edge academic approach. But let's play around a little bit and see what we can even do with existing techniques. In this example, I tested GPT-2, a synthetic text generator, to create some synthetic reviews for movies. In particular, we'd use a language performer which is hosted by Hugging Face, and this transformer uses a starting phrase given by me and then completes it what the model perceives as realistic English language. Keep in mind that such artificial generators typically do not understand what they are doing. It's just a language model which relies on learned language patterns with no real semantic insight. So let's assume I need to create training data for negative movie reviews. I start the generator with a phrase, "This movie is a horrendous piece of," with some extra type is thrown in. The resulting review sounds quite realistic. "This movie is an absolutely horrendous piece of filmmaking, one that is filled with absolutely no story, no characters, and no real sense of purpose." And then it just continues to insult the movie some more. And in the last sentence, it concludes with, "I cannot think of a better way to spend my Saturday than watching it." I'm not really sure if that's a good example of a movie review, but it certainly uses good language. Anyway, such data generators are also interesting tools to generate all kinds of text, and I would invite you to play around with them a little bit yourself. Just check the references on this slide. Just keep in mind that these things indeed have no idea what they are actually doing, and despite using proper English language, will more often than not generate meaningless or factually outright wrong text, which can be quite harmful when used in the wrong way. Just look at this example. "The Netherlands is a hotspot for international drug trafficking," and AI model continues. What now is being generated by the AI is something which sounds very much like a proper news report using mostly proper English language and proper grammar, but is factually wrong on nearly all the statement it makes. Just check it out. Please don't use this technology now to build an automatic fake news internet troll bot. Similar technologies are also being employed for generating artificial images. Here are some examples based on Mini DALL-E, a weaker version of the DALL-E model. I tried to make some images for completely ridiculous training tasks like recognizing penguins in a car or recognizing bicycles made out of cheese. Well, judge for yourself if these results are actually any good. However, more powerful model, when being adjusted correctly and used in the right context, can provide surprisingly convincing training data. See, for example, here, artificially generated images of road signs with a blue strawberry on them. Such images could maybe be used to train a self-driving car on recognizing a new sign being introduced before the sign is actually available. Anyway, as a takeaway, many experts, for example here the Gartner Group, believe that synthetic training data will play a central role in future AI systems and will overtake the use of real data in volume in just a couple of years. To conclude today's session, what did we learn? Good data is hard to come by, and getting it might be potentially very expensive and time-consuming. There are several approaches to obtain data. Summarized, we can reuse data from others, extract it from external data repository, extract it from your own data, use large crowds to make data for you, or fake data using AIs. And with this said, I thank you for today's attention and hope to see you another time.